Hello everyone and welcome to my YouTube channel. So this is a video where I will show you how to run a Coffee Lake 8th or 9th generation CPU on an older motherboard with a 100 or 200 series chipset. So first of all, I'm going to show you it works. Let me just fire up CPU Z. And as you can see, I'm currently running an i5 9600KF on a motherboard that is equipped with an Intel Z170 chipset. So this chipset supports overclocking by unlocking with unlocked CPUs. So I have managed to push this chip to as high as 5.1 gigahertz on AIO liquid cooling. So, and if you have a good motherboard as worthy as this one, or even better maybe, so you will be able to do that too. But you will be also be able to run any 8th gen or 9th gen CPUs on a 100 and 200 series motherboard, and that includes the H110, the B150, or the H270, or any motherboard as such, like any 100 or 200 series motherboard. So in this video I'm going to just show you what you need to do and how to make the modification both via software, that is firmware level changes, as well as the necessary modifications required on the hardware level. So first of all, you will need this tool called CoffeeTime. The version I used was 0.99. It has developed a lot since it was initially released by a member of a forum called WinRaid. So that is how I got to know about this thing in the first place. And you will also need another tool called Aptio V BIOS update utility. So you won't require this directly, but this is just for I will mention you later as I progress along the video. So first, what you need to do is you need to download the stock BIOS for your motherboard. In my case, I am using an ASUS Maximus 8 Ranger. So I will just search for the support page and download the latest BIOS. So this process might vary based on your motherboard manufacturer. So in my case, it is ASUS, and with Gigabyte, you just need to follow the standard procedure for downloading the BIOS file, and then the steps are pretty much the same. So I will just download the BIOS file, and once done, I'm going to extract it to a convenient location. For our ease of use, let's just extract it to our desktop only. So this is our stock BIOS file. So once you have downloaded that, you need to open up CoffeeTime 0.99, or the version we'll be using. Maybe when you see this video, there might be a better version which is released. So I will just fire up this software, and as you can see, it asks for the BIOS file. So I will just click on browse and then browse to the desktop where I have just downloaded our stock BIOS file, and click on continue. Yes, so once this is open, there are a lot of options that you will need to change. It's very easy, it's like pretty much automated. So I will just guide you with the steps. So firstly, we have ME, which stands for Management Engine, and you need to make sure your Management Engine firmware is below 11.8. So with Management Engine 11.8, you won't be able to boot up your system with this modification. So what I will do is, as I can see, it is on the BIOS file, the version is 11.6, but I can of course update it to a more stable or a more recent release, which is known to work with the Coffee Lake CPUs along with this mod. So I will just replace the one that is on the BIOS file, and I just click on this option menu here. I'll get this and just click on replace. So once that is done, I will just like apply all these patches, like the PCI Express patch, the SKU hack, and all these things. So for the SKU hack, I just want to add one point that this is sometimes not required. It really depends on the motherboard. In my case, it was required. I did try flashing the BIOS without the SKU hack, but it did not work. So basically what it does is it when you power up your PC, it tells the CPU that it is equipped with a 300 series chipset, even though it's not. And that way it basically fools the platform that this is a compatible platform, but you know the rest. So I'll just apply this patch as well. And also do note that sometimes this SKU hack, when it is not required, it can affect performance a bit. That is what I read on the forums anyway, so just keep that in mind. As for the same course, you will need it because you are using it on a motherboard which officially supports up to a maximum of 4 core and 8 thread CPUs, which is like we are talking about the i7s, for example, the 6th and 7th generation. So all those chips are 4 cores and 8 threads. So when you put it in a motherboard like this, you will find that without the same cores it is going to work, but all the cores will not have the turbo clocks. Like for example, if you are using a 6 core CPU, you will find that core 5 and core 6 are not boosting to their turbo clocks. So for that you will need sync cores. Then there is initialize 8 plus CPUs, that is 8 thread plus CPUs, so you get that. And as for this is the power management tables, ACPI table. So you will need to patch this, otherwise your system might not boot up. It might not be able to adjust voltages and or the dynamic clock frequencies or the power states that Intel offers. So I'll just click on that. Okay, as for BIOS and GOP, this is for the internal graphics of your CPU. Like, as we know, both the 8th and 9th gen chips come with integrated graphics. You of course have the option for the F variants, which do not come with the graphics subsystem. But in order to use Intel HD graphics without any issues, you will need to make sure these two are updated as well. So what you need to do is just click on this options menu and just select the latest version from the list and click on replace. So all these things are automatic, you don't need to do anything. So as you can see, our BIOS has been updated to version 1062, and as for our GOP version, we are going to do the same. So this is the latest version of the GOP that is confirmed to work with any CPU from the 6th gen to the 9th gen. For the 6th gen, I will talk about it later, and also make sure this option is checked for the best compatibility. So that is done, and now for the fixes. So this is the 16 thread support. Precisely, this has been made for the i9-9900 series, which have 16 which has 16 threads. So you'll need to apply, even if you are not using an Intel i9-9900K, you can of course apply this fix, as it does no harm and ensures better compatibility in case you will want to upgrade your CPU at some later point in time. So you know that it is just going to work just like that. So I have applied that anyway. So that is done. And as for the PCI Express 1440, you really don't need to apply this unless you are planning to use a laptop chip with this. You will know what I mean. Let me just show you. So you might have seen a video from TechESCT or Linus Tech Tips where they have successfully used a laptop CPU. So this is the one I'm talking about. So you can see you can get this chip from AliExpress for a very cheap price. Like let's face it, this is equivalent to a to an Intel Core i9 9900K. Even this is even an unlocked CPU. So like you what you need, what you can do is you can buy this chip and you can use this BIOS to, you know, make this supported. Like what this does is it comes with an adapter which will fit perfectly in your socket, and you just boot up your system and it works just like that. So I have applied this fix as well, even though I am not using a 1440 BGA CPU, that is a laptop CPU, but it does no harm and I have just left it. And as for the FD locks, this is actually optional. You really don't need this, and I have not selected it in my case as well because it can compromise security a bit. That is, FD means firmware descriptor. It is the firmware descriptor of your BIOS. So this is the region which contains your Ethernet MAC address, your board serial number, the UUID data, and all those licenses. Like if your board came with a DTS or Dolby Digital license, then those things are stored in the firmware descriptor region. So, and as for this thing, this is very important, and these like this section contains the CPU microcodes. So as you can see, I have not made any modifications yet, and this contains just the basic microcodes for the 6th generation and the 7th generation CPUs, like this, what this board natively supports. So what I will do is I will click on this options button and then add the necessary microcodes. So for 8th and 9th generation CPUs, you need to first identify your CPU stepping. That is, in my case, I could have just gotten away with 906ED, because if you check CPU Z, let me just fire it up. So this is the one I'm talking about. So you can see my other revision of my CPU is R0, and it's 6ED, that is family 6 model E stepping D. So you might wonder that how will you know this beforehand? That is, you need to know this before you put the CPU in, and if you put the CPU in without the modification, your system is just not going to boot. So here's how. So in the Intel CPUs, you get a spec code which is printed on top of your CPU. So in my case, for the i5 9600KF, it is SR G12. And if you search for SR G12, you will get all these details from any like good third-party site. I just followed CPU World, and here you can see all these details are mentioned, and that even you can find, I think you can find the R0 stepping somewhere here as well. So okay, I cannot see that, but it is there somewhere. Yeah, I think this is the one. That's not the one. Yeah, here it is. So you can see there are two spec codes for the 9600K. One is SR FAD, which is the P0 stepping, and one is the SR G12, which is the R0 stepping. So this is the one I have. I'll just do one thing. I'll just show you the photo of my CPU which I have, and let me just bring it out. So here you can see it's SR G12. So that's all you need to do. So once you do that, you will find which microcode you need. But in my case, I knew that this board I have has a 128 MB BIOS chip, and that it might be possible that I can include all the microcodes for the 8th and 9th generation CPUs, as well as keep existing my compatibility. So I initially selected all the microcodes I could. So that is, these are already existing. These are just the different versions. These are the latest versions, by the way, as of this time. So I did select all of this. So you really don't need these unless you are planning to use an engineering sample CPU for the 6th generation. So all the 506 E1, E8, E3, these are all microcodes for the 6th generation CPUs, and this is for the 7th gen, that is the Kaby Lake platform. And all the 906 EA, EB, EC, and ED, these are for the 8th and 9th gen chips. So what you do is like you click on this replace button, and that's it. As you can see, this BIOS file is completely upgradable with all these microcodes, and that way we can ensure maximum compatibility across any CPU, any LGA 1151 based CPU. So you can just drop it in the socket and it is just going to work. So then you go to this extra tab, and this is what I did. I'm not using a 128 GB RAM in this motherboard, but you can add support. Let us just fire up Intel spec. So if you search for i5 9600KF, you will see that this supports a maximum of 128 GB of RAM. So let me just scroll down and see the maximum memory size is 128 GB. And if you check, for example, any Kaby Lake CPU, let's say i5 7600K, this was the CPU I was using before I got this upgrade. So you can see this supports a maximum of 64 gigs of RAM. So you can see that. So that way this basically adds 128 GB of RAM support. So I did that anyway to just make sure it is compatible and possibly better compatibility. SPD Right Protection, you don't really need it. I have left as it is, and anyway ASUS BIOS allows you to, like ASUS Republic of Gamers BIOS allows you to disable SPD Right Protection anyway. So you can just leave this. If you are using a rogue motherboard, if you're not using an ASUS rogue motherboard, you can just disable SPD Right Protection. So you can flash the SPD chip of your RAM and maybe save your overclock settings on that only. And but I have left this as disabled. And hex to decimal CPU count, so you see by default these motherboard BIOSes like these, the 100 series chipsets, these use hexadecimal to show you the number of CPU core count or the CPU thread count. But in case of, say for example, an i9-9900K, it has got 8 cores and 16 threads. Now that 16 is a number which the hex cannot display, so that it needs to be converted into decimal, and that is exactly what this patch is going to do. So I have applied it just in case, and just because if I will get a i9-9900K later on and upgrade to that. Because this is a very good motherboard. And as for these things, you can leave it. Now there is full compatibility with all these things. And for the default RAM frequency, you don't need to change it unless you're planning to using a laptop based CPU. So laptop CPUs often does not support high frequency RAMs, and by default you can set the memory frequency to something that is that the laptop chip is known to work with. So like currently it is at auto, that is the motherboard will basically pull the data from the SPD of the RAM and configure accordingly. And then you can of course enable the XMP profile if your RAM supports it. But in any case, if you find any sort of memory related issues with the default settings, you can change that auto setting to something which is known to work, so that when you put that chip in, it is going to work just like that. And then you can of course further tune your memory settings based on your preferences and the maximum capabilities of your system. So once this is done, we are ready with the BIOS file. So we're just going to save image and just save it. Let's save it on the desktop only. Let's name this M8R, which stands for Maximus 8 Ranger Modded. Okay, so and we just click on save. That's it. So our BIOS file will be here shortly. Yeah, it's there. So here we have our BIOS file. So now you can directly flash this BIOS, but there is a problem. You will lose some specific board data like your MAC address and the serial number and the UUID and any licenses that your board might have came with, like the DTS license, DTS audio license, the Dolby Digital license, maybe the Windows license as well. So of course you can manually add all these things if you have the stickers on your motherboard, or if you have the box you can add these things, but I just wanted to do it as properly as possible, so I will just show you how it can be done. So I'll just close CoffeeTime for now, and now what you need to do here, here's where Aptio 5, this tool will come in handy. So what you need to do is you need to fire up this software, and like I will be using the 64-bit version, and we are just going to click on this and open this software, and once done it is going to show you basic information about your system. So what you need to do is you need to click on save, and it will ask for a location, and you need to save the dump of the BIOS file that is already on your system, like at present what is already there, which includes your board serial number and UUID, so and of course the MAC address. So once, I will not save it now because it will definitely pause the video recording and everything, since it's a low level access. So once done, you need to this is the file I saved already. So there's another tool that you will need, and that is called FD44 editor. Let's just put it in the desktop for our convenience. So once you download FD44 editor, just open the software. It's a very tiny and very it's very good software. So just open it and click on open from BIOS file, and now select your source BIOS file. Let me show you again. See, it says open from BIOS file, so this is your source BIOS file. So I'll just click on that and then browse to the BIOS file I just saved, that is the dump I took with this Aptio 5 utility. So I'll just select this one and just ignore this warning if it comes, and see here you can see all the information like your MAC address, your UUID, your motherboard serial number, and everything that is there. My motherboard did not come with a DTS license, so as you can see this is empty. So what I will do is I will just click on save to BIOS file. So this is your target BIOS file. Now I'll just click on save to BIOS file, select our modified BIOS file, that is this one, that one we made with CoffeeTime, and just click on save. So it asks whether you want to replace the file. Just click on yes, and just it is done. That's all that is needed. So this file is now ready to be flashed in your motherboard BIOS. So if you want to cross check whether your information is actually written on this BIOS, so you can just fire up CoffeeTime again. Let me just show it to you. So let us select that file again. This is the one. Yeah, so that's it. So you can see the MAC address, the serial number, the UUID, everything is there. So it's very easy basically. So this BIOS, this is ready to be flashed in your motherboard. So now that we have prepared the BIOS, there are some steps we need to take for the hardware level stuff. So let's get on to that. So here in Coffee Tool you can see a section called pin mount map. So just click here and you will see an image that comes. So depending on your motherboard, you will need to connect and isolate some of the pins on your CPU to prevent from to ensure maximum compatibility and also to prevent damage in some cases. So basically how this thing works is basically some users got their hands on the pin contacts of these Kaby Lake and Coffee Lake chips. So I will just show you what the differences are. This is the Kaby Lake pin layout, and this is the Coffee Lake pin layout. Where is it? Yeah, this one. So you can see this is very similar. However, in some cases, like see in Kaby Lake, these pins are reserved, whereas these pins are VCC. So you will need to make sure that if you have a motherboard where these reserved pins are connected, then you will need to isolate these pins. So people, like, luckily a lot of users have already done this, and like the tutorial is quite rare, and that is one of the reasons I'm doing this, for convenience to you guys and for anyone who wants to give this a shot on their older but totally capable motherboards. So you can see this is one of the reserve pins. Then these are all reserve pins in the Kaby Lake, but these are all VCC pins in the Coffee Lake. So you know what, if suppose your motherboard have these reserve pins connected somewhere, even if to ground, and if you connect a Coffee Lake CPUs, then these pins are going to burn out, or it might cause catastrophic damage to your motherboard or processor, or both. So that is why, based on these pin configurations, this pin mod has been made. So in case of my board, I did not need to isolate anything. I just needed to connect these two pins, which I will show it to you just now. So let me just show you the mod. This is the one. So you can see I put in a very small copper tip. This was a self-adhesive copper tip that I salvaged from an old smartphone, non-functional smartphone, and I just cut it to perfection and fit it here so that it is enough to touch those two pins on the socket. So on side note, you don't need to really connect the pins on the processor, rather you need to connect the pins on your motherboard. So on the that is a motherboard pin. So I did not really care whether the adhesive was acting as an insulation for the pins. As long as it is shorting the pins on the motherboard, it is going to be just fine. So I did that, and I flashed the BIOS, and now I will get to the flashing part, and it booted up just fine. So now for the flashing part. For the flashing part, you will need a third-party programmer. Your motherboard internal BIOS flashing tool is most likely not going to work, because this is a modified BIOS file and your motherboard will be aware of that. So to get past that, I did buy an external BIOS programming tool called the CH341A. So this is the exact one that I bought. This is very cheap and it's very good. The software is somewhat difficult to find, but yeah, if you just need the software, just let me know in the comments below, and I will give you a link of the software, or I will just update the video description. So all you need to do is you need to buy this thing. You need to pull out the BIOS chip from your motherboard or connect some wires physically, and then you can just flash the BIOS with this. Of course, you will need a separate computer for that, or a laptop PC, but you get my point. So this is how it looks like. Let me just show you the BIOS chip. In my case, that is in the Maximus 8 Ranger, the BIOS chip was removable. Let me just show you how it looks. Any random photo will do. Yeah, as you can see, this is the BIOS chip we are talking about here. It's basically socketed. I was very lucky that way. I did not had to do any soldering with respect to this, and like I pulled out the BIOS chip, connected it in the flasher, and just flashed it using the software. So as for how it looks, I will just show you in a sec. So I had this article in Tech Power Up I published a few months back. This is the one I wrote. So this is basically a thread of mine where I faced a different kind of issue, but I will show you some of the photos here. So this is how it looks like. This is the BIOS chip where you connect the BIOS chip, and this is how the software looks. Right? This is the programmer software. You open the BIOS file. You first erase the BIOS file. First erase the chip, and then open the new BIOS file. That is the one we prepared with all the serial number updated and everything. And then you need to write or program that file into your BIOS, and once you do that and you put it back, like this is exactly my board, and once you put it back, it is going to work. And so once I checked everything was fine, I tested everything from overclocking to RAM frequency tuning. I'll just show you in a while. And I must say I was very impressed with this mod. Like, I'm using this system as my daily driver, and this is my second PC basically. It is my work PC as well. I use it for a little bit of gaming as well. You can see I have a RTX 2060 Super in this. It performs very well. Like, I have a different system as well with the Ryzen 5 3600, and this system performs better in games than that system, maybe because of Intel's superior single thread performance or better memory latencies. I've got no idea why that is happening, but this system is performing superb. I will show you the benchmarks in a while. So I overclocked the CPU, then I also overclocked the uncore frequency, that is NB frequency, which it is called. The RAMs I'm using with this build are very cheap actually. These are Xeon made RAMs. Xeon is an Indian company, by the way. They make good products, but this the one I have is one of the entry-level ones, and these are 2666 megahertz unit. I managed to overclock them to 3000 megahertz at these timings. These are quite high for 3000 megahertz, but it performs very well. So I'll just show you. These are dual channel kits, by the way, and let me just fire up ADS64 where you will be able to see what I am talking about. So if I do the memory benchmark, you will see these are very good scores actually for a platform like this. So you see all these are above 40 GB per second, so that's very impressive for a system like this. And I should say it performs, at least with respect to memory bandwidth, it performs superior to the Ryzen processors, and that is probably one of the reasons why gaming performance is better on this Intel platform. So latency, now that I am recording the screen, it is 57.3, but usually it stays around the 51 range, whether it's 51.2 ns or 3 ns. I don't remember exactly. I might have a screenshot. I will try to find that later on. So yeah, and as for everything else is working. I'll just show you the power management as well. So as you can see, I have this set it to high performance, but if I set it to balanced, you will see the CPU clock frequency is dynamically adjusted. This is the Intel speed step technology kicking in. So now that I'm recording the screen, the frequencies are a bit higher on the higher side, but if the system is idle, it goes to as low as 800 megahertz, which is the minimum allowed clock for this CPU. So everything works. Like, you can see even the by the way, you can see the voltage is quite high, but this is reported, like, this is very common. This is the SVID, the thing that is known to many users. You can of course monitor mode accordingly with HW Info 64. Let me just download it and show it to you what I mean. By the way, the voltage I'm using for my 9600K at 5.1 gigahertz is about 1.35 volts, so that's very nice, I would say. And I'm using a liquid cooler. It's a very old one. It's a Cooler Master Cedon 120V. It's about 7 years old, but it works perfectly fine. So I'm just keeping it for now. Maybe I will upgrade to a better cooler later on. So if I fire up HW Info 64, let's see. So you can see all the basic details here, and now for the voltage, which I wanted to show you. So you will get the real, that's the actual voltage from this software here. So let's check that. So this is the temperature reported by the motherboard. All these voltages, vCore. You can see these. The vCore is very high, you might think, but let me just show you what it really is. So where is that thing? Maybe I missed it somewhere. Okay. See, this is the one I'm talking about. See the voltages. They're like the maximum voltage is 1.35 volt, maybe when it boosted to around 5.1 gigahertz. These are very good voltages. You can keep them for 24/7 usage. So Intel recommends a maximum of 1.52 volts for the 8th and 9th generation Coffee Lake chips, but like you are going to be just fine. So this is the things, a few of my settings. And as for overclocking, you can refer to other guides as well where they are available. So I just wanted to show you this, like overclocking is nothing difficult. And now I am going to show you how to ensure full compatibility. Like you might be wondering that this thing might be risky, this mod I'm talking about. Yes, so if you require this mod, you might be a little bit paranoid. I was actually. So you might think that this copper tape might fall off and possibly short something else on the other pins, or whatever it might. The adhesive underneath this tape might cause a mess of your CPU socket. So I was concerned with that. Really, I was not like ready to use this kind of mod as a 24/7 usage or as a daily driver. So here's what I did. So what this is called is SKT OCC, or socket occupied. So you know, your motherboard needs to know that the CPU is inserted in the socket, and the way these Coffee Lake CPUs are designed, this SKT OCC pin is basically somewhere here, not like in the KB Lake. Basically in KB Lake or Sky Lake, the pins are here, and hence you require to short this. So here's what I did. So let me just show you some. So this is the one thing I was talking about regarding the SKT OCC mod. So you can see this is one of the chips on this Maximus 8 Ranger motherboard, and it's a Super IO controller, and this chip is basically responsible for telling the motherboard if a CPU is present, and also for monitoring the voltages, the temperatures, the fan RPMs, and everything else, things like the monitoring section and everything. So there's a sensing circuit here which basically tells the motherboard that if a CPU is inserted, and whether if the motherboard is okay to be powered on. That is, when you push the power button, it basically turns on and provides power to your CPU, RAM, and everything connected to the board. So basically what I did was I followed the datasheet of this chip. So firstly, let me tell you what happens when you don't put this. So if you don't put this, like even if you have flashed the BIOS and you have not put this tape here, or you have not made this modification, so your board will simply not start. You will get no power, nothing. So it will behave the same as if no CPU is inserted. Okay, so basically my objective was to try to like achieve what this copper tape was doing without this copper tape in there. Like it is just going to be plug and play. I wanted it to be plug and play. So what I did was I checked the Super IO. Like I knew that this chip was the one chip responsible for basically telling the motherboard to turn on, or telling the motherboard that the socket is occupied, and hence the name SKTOCC, or socket occupied. So that is the name of the pins which I previously mentioned. So this chip I had downloaded the data sheet, and I will just show you. So these are the pinouts of the chip, and you can see pin number 102, it's called SKTOCC. It's called SKTOCC. So what this pin does is basically this is the pin that connects to that SKTOCC pin of the CPU socket. Okay, and what it does is basically when you put a compatible CPU, that is when an officially compatible CPU, let me just change my statement. So if you put a Skylake or Coffee Lake CPU, what it does is the CPU basically shorts this SKTOCC pin to ground. That is, the CPU is electrically made that way. Okay, so basically for the motherboard to think a CPU is present, this pin needs to be grounded, and that's exactly what I did. So let me just show you the photo again. So this is the modification I did, as you can see in this yellow rectangle. So pin number 102, if you remember, let me just open that photo as well in parallel. So it's pin number 102, and the chip pin number 1 is here. That is when that the NCT6793D marking is there. So as you see, it's upside down, and pin number 1 is here. As you can see, it's marked. So in this motherboard, basically it was easier to identify the pins. Well, basically every fifth pin is marked, like this is 1, this is 5th pin, this is 10th pin, the 15th pin is not really visible, this is the 20th pin, and you get it. So this is the 97th pin where it's written 97. This is 98, 99, 100. This is the 100th pin where you can see this white line. This is the 101, and this is the 102 pin, this one. So this trace, you need to be good with circuits to understand that. That's why I mentioned that if you're not comfortable doing this, you can seek help from a professional motherboard repair shop or people who does this kind of things. So what I did was I followed the trace, this trace that you can see, and this is going in this resistor, this one. And so this resistor end is basically pin number 102 or the SKT OCC, and all I needed to do was connect this to ground. And with the multimeter I checked for any nearby ground pads present, and surely I found one, which is this one here. So you might ask me why I did not connect it vertically, since this resistor should be a 0 ohm resistor, but it's not. I checked it with multimeter and it's not. And to further cross check my findings, I put my i5 7600K CPU, which is officially supported on this board, and I checked in DAD mode resistance with multimeter that this pin was getting grounded, but not this one. So with the CPU in the socket, that is the 7600K, which is an officially supported CPU in the socket, this pin was getting grounded. That is the one I connected the wire to on the end of the resistor, but not the other end of it, and hence this diagonal mod was required. So I just very carefully soldered a tiny piece of wire in between this, and to check this modification, what I did was I removed everything else. I removed the CPU, the RAM, everything, all those things, the cooler, the fans, everything, and I just connected the power supply and powered the board on, because without the CPU the board will think that the CPU is inserted and it will power on, and it was successful. Of course I got a 00 error code, which means CPU error or CPU not initialized, which is common because I don't have a CPU in the socket. But my objective was fulfilled, that is the motherboard is able to power on without having a CPU in the socket. So it was at that time I put the 9600KF perfectly for the final time, and I have no plans to remove the cooler anytime soon. This is how it looks, by the way, and then I will show you a better photo as well. This is how it looks. You can see this is a spec, this was the spec code I was talking to you about, and I put it back, I connected everything else, and it fired up in one shot, no questions asked. So that's all for this video. Like now that's not all for this video, like I mean that's all for the tutorial. So as for the serial number and UUID, everything is just the way it was before, and the best part is that, let me just show you the serial number first. Oops, sorry. So you can see the UUID, the serial number, everything is just the way it was before. So this has been a breakthrough, I would say, because this motherboard, it is a very worthy motherboard of running these kind of CPUs, and even people have success running the i9 9900K on this very board that I am using. And it has been very helpful. I was using an i5 7600K, which you might know is a 4-core 8-thread part. I was running it overclocked at 4.9 gigahertz, but it was struggling in the modern day-to-day scenarios, especially with games. It was struggling in video editing, it was struggling, but now I have a very capable 6-core 6-threaded chip with room for upgrades, and I can put in an i7 9700K or an i9 9900K and just call it a day. Just like that, it will be just plug and play in the socket. So, and with the power management, everything working, So it's a win, I would say. And you might ask, you might have the question that who is this mod really for? So, and here's the thing. So if you ever got a good board like the one I have, as worthy as this one, or even better maybe, let's say the tough saber tooth Z170 series, or the MSI Z170 series, or the premium lineup, or maybe one from Gigabyte. So you might want to give this a shot. Like if you're looking for an upgrade and you have got nothing to lose out of your old build, I would say if you can get a deal out of an 8th gen or a 9th gen chip, which is that includes the i7 and the i9 units, you can give it a shot. You might ask me why I went for the 9600K, and the reason is very simple. It's the cost, and I got it for a steal price. I will just show it to you. So I'll just fire up Amazon.in, search for 9600KF, and let's just open this and I will show you my order details. So you can see it's a recent purchase I made, and this chip cost me only 14,316 rupees. That's a great deal, I would say. This is basically, this chip is cheaper than the Ryzen 5 3500X, while both are 6-core 6-threaded chips. Yes, sure, the Ryzen 5 3500X has PCI Express 4.2 and nothing else. I don't think that it's superior by any other means. So it just got PCI Express 4.0, so you can of course opt for faster storage there. But is it really practical? I don't think so. I think if you're looking for an outright upgrade out of your old but very capable motherboard, and don't want to break the bank, don't want to buy a new motherboard of that tier, then I would say just go this way. It just work wonders. And as for how it performs, let me just show you some screenshots which I have captured over time, and I have uploaded some scores on HWBot as well. So I have logged everything, all of these things, and just let me show you. This was the I connected one of my NVMe drives. I'm still using an NVMe drive. It's a Crucial P1. It's not very high end. This is the one I am using now. It's good enough. It's not the best, but it's a quality drive and I can rely on it. I know that. But the thing is, I have a 1 TB Samsung NVMe on my laptop. It's a PM981A. Basically, it's just the OEM version of the 970 Evo Plus, and you can see the scores speak for themselves. The sequential read and write speed, like there's literally no bottleneck in terms of storage with PCI Express 3.0. This motherboard has one NVMe slot, and I have planned to add another one with the help of a PCI Express adapter. This motherboard has a PCI Express X4 slot at the bottom, which I will plan to use it that way. So I wanted to show you this, and in case you are doubting, this is the exact motherboard I am using. You can see I have pulled out the Idea 64 information as well for you. And for the gaming benchmarks, let's just dig into that. So I fired up Horizon Zero Dawn. I ran quite a number of test runs. This is with the 7600K, I think. Yes. So see, this is what I wanted to show you. With the 7600K at 4.9 gigahertz, this was the CPU I was using previously with this very same motherboard. So if you compare the frame rate, the average frame rate is not much different. This is what I got with the 9600K. But if you see the 99%, the 95%, and the minimum frame rate, you will see what I mean. You will see what I mean. See, the minimum frame rate's down to 27, and mind you, this is not exactly a CPU intensive game, so keep that in mind. With Cyberpunk 2077, I've had even better results. Cyberpunk 2077 used to badly stutter on the 7600K, even at 4.9 gigahertz, using the very same GPU. I'm using a 2060 Super, as I mentioned before. It's from Galax, and I did overclock it by 200 megahertz on the core and 850 megahertz on the memory, just to check it, like how much bottleneck there actually is. And based on findings that I see on the internet with some hardware combinations, my set of hardware that I own is very limited, but I checked benchmarks of fellow people who were using the same combo or with different GPUs, even better ones like the RTX 3070. It seems with the 9600K, if there is really not much of a bottleneck if you're planning to even play competitive titles like Call of Duty Warzone Amazon or things like that, and it's good for 144 FPS, let me assure you that. So, and of course you can go the more expensive route, that is you can get an i7 9700K or an i9 9900K, which is the best chip you can get for this platform, and that's it. As for references, I just want to give a huge shout out to WinRate forums, from where I got this information. So just like, let me just show you, this is the thing I searched for, and these links put me as to why I'm making this video. So I read each and every page out of all these threads, and I knew what I was signing up for, whether there are any risks or anything. And I even posted here, you will find my post here, as I have shared my BIOS file also, not the one with my serial number of course, but yeah, I can make it for you if you want. So you will need to flash it yourself, of course. So yeah, that's it. So I hope you like, if you are having a motherboard similar to this one, which is otherwise completely capable to run this kind of chips, then I would say just go for it. If you don't want to, like, especially at this time when everything is so much expensive, like the Ryzen chips, I don't want to talk about them even. Like this 9600K, when like, let me also tell you one thing. Most of the 9600K chips, they overclock to around 4.9 gigahertz mark. I was lucky that way. I was able to push mine to 5.1 and even 5.2, but with 5.2 I was like hitting thermal, I was being thermally bound. The CPU was thermal throttling in stress test, and I was not really comfortable with the temperatures that it was having. So I just pushed it down a bit, reduce the voltage a bit, and this is what I was happy with. And I would say just if you have this kind of board, just go for it without any second thought, and just make sure you're getting a good deal out of these chips, whether it is Amazon, whether you are getting it used from someone. Just try to get a good deal out of it. And these chips, even today, these are very relevant processors, even at this time. So that's it for this video. I hope this is helpful to you in some way. Do let me know if you have any questions, or if you want any of this or any guidance regarding it. I will try my best to answer your queries. If you are not comfortable modifying your BIOS yourself, you can just comment down below with your motherboard model, and I will do my best to prepare the BIOS file for you and then guide you with the flashing process or anything. So that's it for this video. Thank you for watching, and stay safe everyone. Have a great day. Thank you everyone.